Hello and welcome back once again. So continuing on with our VertexCache system in this video, he's going to be implementing our add and our AddNeighbors methods.
Yep. All right. So let's start with our add. So this will be this case, let's make it a private. No, I'm going to keep with my notes for now, just in case I decide to change this later.
Okay.
So we're going to make it a public static. And this will return a vertex. We'll call it add. It's going to take in a vector2 position. It's going to take in a boolean, which is going to indicate whether or not we want to hold this particular vertex. And we're going to take in another boolean, which is going to determine whether or not we're going to add neighbors with this vertex when it's added. And I'm going to default it to be true. And from here, we'll go ahead and say 1 plus 1 equals 2. Okay, we're done with that.
Yeah.
Wish it was that simple. All right, now, first thing we need to do with our add is we need to find out whether or not we've already put this vertex into our dictionary. So we'll do a check on vertices and say, does it contain key position? So if we've already got this in our vertex, we're going to check to see if we are calling hold on it. And if hold versus hold equals true. So what we're going to do is basically check to see if hold is true. If hold is true, we're going to set this position's hold. Or this vertex in this position in the dictionary's hold to be true. And then we're going to return this particular vertex or vertex.
Very good.
But all right, the reason this is the way it is the fact that if we already have the vertex in the system, we don't want to recreate it. Otherwise, there's no point in having a cache if we're going to recreate everything every single time.
Right.
But if for some reason this has been flagged to be held, we want to make sure that it's hold is set to true. So that's just to prevent the purging system from going in later and potentially trying to remove this particular vertex from the system.
Okay.
So invert. No, I don't want to invert. I was hoping ReSharper maybe came up with a really cool idea, but it didn't. All right, next we're going to make a field called vertex. This vertex is going to equal a new vertex. And we need to pass in a position, which is going to be a new vector 3. And our position will be position.x, 0, position.y. Because we're taking in a 2D vector for our position. We want to convert it to a 3D with y set to 0.
Right.
So that's going to equal that. And I'm going to go ahead and set, come on. All right, we're going to set its height. So height will equal get height position. And let me clean, oh great, come on. One of these days I'm going to have to go into the settings and fix that, because it's kind of annoying. And watch, I put semicolon and it changes it. Fine, I'm not doing it again. All right, so basically all we're doing is we're creating a new vertex, converting the 2D position to a 3D location with a 0 height, which we then go and get from our get height method, which then goes to the train generator, calculates the information, sticks the height in there. Now, the next step I would do would be assign the vertex color, but because we're going to skip that for now, I'm not going to do that. What I will do, though, is I'm going to lock our vertices. So this is going to lock the dictionary because I'm about to add something to this dictionary. And there's the potential that this could be going on at the same time that the purge thread is trying to remove vertices. And I don't want both of those to happen at the same time because very bad things could potentially happen. So we're going to lock the dictionary so I can go ahead and add the vertex we just created. We're going to give it position as its key, and we're going to send in vertex as its value. Do a couple of checks. Basically, this is similar as before. We're going to check hold. If hold is set to true, we're going to take this vertex's hold, and set it equal to true. And then we'll go ahead and check to see if we have flagged add neighbors. So if we have said add neighbors, we're going to add those neighbors. We don't have that method yet, so let's go ahead and add it. No, that's not what I want yet. I want to create a method. There, good. So now we've got add neighbors. We'll come back and fill that in a sec. And the last thing we're going to do is return vertex. So this is going to return the vertex. So at any time we call add, we're either going to return a vertex that is already in our dictionary or already in the cache, or we're going to create a new one, add it to the cache, set its initial values, and then return it. And we also have the ability to add neighbors. Now, the whole reason this exists is the fact that when we run our program, matter of fact, I think with this we can still run our program just fine. Let's jump over to Unity and I can show what's going on. So go ahead and run this, give it a sec to spin up, and we get some train. All right, now if I go ahead, zoom in on some of our train, particularly this spot right here, and let's go ahead and take our material, and I'm going to take the actual material and I'm going to set our texture to none. And then I'm going to set our normal map to none. And we can see that we're getting some seams. Now these seams are caused because of the fact that the Unity importer is calculating our tangents and our normals for us. It only knows the vertex information that is part of this patch. It has no idea whatsoever that there are vertices surrounding this particular patch that it could use to calculate the correct tangent and the correct normal at this point. What add neighbors is going to do for us is to basically give us the ability that when we add a vertex into the system, it will add all of the surrounding vertices. So with and I closed out Photoshop. I was going to show it too, but let's just use the grid here for demonstration. So let's say that this is our vertex right in the center. When we add this vertex and we set add neighbors to true, it's going to go and add the other 8 neighboring vertices. This will ensure that when we do a calculate normal and a calculate tangent operation on this particular vertex, we have all the information that we need to correctly calculate that vertex's normal and alpha, or normal and tangent, which will allow us to eliminate that seaming issue. And it's also kind of a prefetch, because what you find is when you're adding these neighbors, you end up eventually grabbing the vertices ahead of time. So let's say we start with one of the vertexes inside of our mesh. We grab all the neighbors. Well, if that one vertex was towards the center of our mesh, it's already grabbed the other 8 vertices that it needs. If they're not in the system, it already has calculated that before we even ask for it.
Mm-hmm.
So we do get some optimization eventually, particularly when we hit neighboring patches. Because let's say we generate all the vertices for one patch, then the 8 surrounding patches already have some of the vertices calculated with the side that's common between all of them. But on the flip side, there becomes an issue. Let's say we load in a patch and we get all of the surrounding vertices that come along with it. And then let's say we just run in a straight line. We never deviate. So we're running straight up the line. Well, what ends up happening is we end up with these rows to the left and right of the patch that we're on. And as we move up, we've got these patches to the left and right that are never used because we never load in the patches to the left and right of the direction, just the ones directly above us. Well, what ends up happening is that it becomes a memory leak because those vertices just stay there because they're not technically part of that patch. Because when we delete a patch, the patch just deletes the vertices that are part of it. Because these were neighbors to vertices in that patch, the system doesn't know about those, which is why we have the time to live operation. So it goes back and cleans that up.
Okay.
So as far as how do we add neighbors? Well, add neighbors is going to be fairly straightforward in that all we do is we call add and we take our position. And to our position, we add a new vector 2. And I probably should tell this to take in a position, which is vector 2 position. And then each one of these will be a spacing away from our current position. So we'll start off in the upper left-hand corner, which will be a negative spacing in the X and a positive spacing in the Y. Then do we want to hold these particular vertices? No, we don't. So we send in false. Now, if another patch comes along and uses these vertices, then it will set these vertices, which is why we have this line up here. So there is the possibility of adding vertices that aren't being held. But then when another mesh decides it needs to use them and finds that they're already in the cache, then it's going to flag these to be held.
Okay.
And then from there is, do we want to add neighbors of the neighbors? No, we do not. So we only add neighbors for original vertices that we call ourselves. The neighbors are not going to continue to add other neighbors. Otherwise, technically you would find it recursing and adding vertices until it ran out of memory and Unity exploded.
Bad.
Not that I've ever done that.
Okay.
All right. Now, we've already said that there are going to be 8 vertices or 8 neighbors. So we're going to need 8 of these add neighbors. So the second one will be 0 and then a spacing. So basically these first 3 are the top row of vertices. And then we'll have the middle row, which only has 2. And then we have the bottom row, which has 3. So that will give us our neighbors. So this is going to complain because we need to pass in our position. So we pass in position. And that gives us our add and our add neighbors methods, which is everything I wanted to cover in this video.
Awesome. All right. Well, And that means we've got coming up in the next video the indexer. Da-da-da.
Oh, it sounds so mysterious.
Yeah, that's going to be a short video. Well, anyways, thank you guys very much, and that's going to wrap up this video. We'll see you guys in the next.